Welcome. In this video, we continue our unit on lines. We will look at 4 sections from 2.3, sections 3, 4, 5, and 6. And the big idea in all of these objectives is we want to see the connection between equations and lines. To me, this is one of the neat things in algebra, showing this connection. The equations are something very much just symbolic, and the lines are graphical objects. Let's take a look. Let's consider some of the simplest equations that we can graph as lines and how I turn an equation into a line. So consider this equation, y equals 2x. What does this mean? I want to graph all the points x, comma, y, and I'll graph these in the plane where the y value equals twice the x value. So for example, a point would be something like the point 1, 2. Because the y value is twice the x value, and 2, 4, the y value is twice the x. Even something like -3, -6, in this case again the y value is twice the x value, and things like 0, 0, because the y value 0 is twice the x value 0. Okay, so let's plot a few of these things. 0, 0, 1, 2, 2, 4, -3, -6. I can come all the way down about there. And we see that if I were to plot all these lines, -2, -4, -1, -2, or rather, if I were to plot all these points, they all lie on a line. And there's a lot of points I didn't plot, even something like 1.5, 3, or -2.5, -5, or 1.7, 3.4. So all the points, not just the points that have integer values. What about the equation y equals x? Well, these points have forms like 1, 1, or 3, 3, or again 0, 0 is on there, -2, -2, all those points where the x value equals the y value. So let's see here, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, -1, -1, -2, -2, and so on. And so if I graph all the points, not just those points with integer values, but all the points where the x value equals the y value, I have the line that represents the equation y equals x. And a third example, what about the equation y equals 1/2 x? So this is telling me I'm making a bunch of points, and the y value is half of the x value. So something like 2, 1 works, but also even something like 1 and 0.5 works, because the y value is half as much as the x. Or how about -4, -2? So -4, -2, something like that. -2, -1, 0, 0, 2, 1, 4, 2. And when I graph all the points where my y value is half the x value, I end up with that line. So there's the start of how we see this connection between equations on the left and lines on the right. A line isn't really just one long line. You should think of it as a bunch of points. A line is really a collection of points, and the x, y coordinates satisfy that equation. All right, let's take a look at some vertical and horizontal lines. How would you graph the line y equals 3? And this is a little confusing at first because there's no x. What about the x? Well, the idea is, since there's no x, x can be anything. There's no restriction on the x, but there is a restriction that y equals 3. So what are all the points where the y coordinate is 3? That looks like this. It's a horizontal line with height 3. So I can look at various points on this thing, like the point -4, 3, and the y value is 3. Here's a point -2, 3, and the y value is 3. Here's another point, 4, 3, and again the y value is 3. The x value can be anything, but I am restricted that the y value has to be 3. Now let's graph the equation x equals -2. So again, the non-existence of the y tells me that y can be anything. Y is not restricted. My only restriction is that x equals -2. So this looks like a vertical line. A vertical line going through -2. So again, I'll pick a couple points. -2, -3, -2, -1, and there's the point where they cross, -2, 3. Along this purple line, y coordinates can be anything, but the x coordinate must be a -2. Just in summary, if I have an equation of the form x equals a number, that is a vertical line, and if I have an equation y equals something, that is a horizontal line. Now, we start with one of our standard forms of an equation, the point-slope form. This is very useful. I use this in calculus all the time, the point-slope form of the equation of a line. Let's see how we get that. Consider the line going through the point 3, 1, 3, 1, with slope 2. All right, so I will make a line that has slope 2 going through 3, 1. There we go. Let x, y be an arbitrary point on this line. So let's see here. The point that I chose was 3, 1. Let's just make something else over here that is x, y. I can calculate the slope by doing a change in x and a change in y. My change in x is x minus 3, and my change in y is y minus 1. So the slope is change in y over change in x. Y minus 1 over x minus 3, and that equals 2. So let's multiply both sides by x minus 3, and I end up with y minus 1 equals 2 times x minus 3. That is the point-slope form of the equation of this line. Y minus 1 equals 2 times x minus 3. We can see sort of the remnants of the point. I have the 3 and the 1. I can pick those out. And I have the remnants of the slope. The slope is in there too, that 2. In general, if a line goes through some point x1, y1, okay, I'll just draw this, x1, y1, with slope m, the point-slope form of the equation is y minus y1 equals m times x minus x1. This is worth memorizing. It will come up again and again. So y minus y1 equals m times the quantity x minus x1. And it comes, again, just from the calculation of slope, where x1, y1 is some particular point, xy is an arbitrary point. We can calculate the slope. The change in x is x minus x1. The change in y is y minus y1. And that's where the calculation comes from. My y minus y1 over x minus x1 equals m. And when I multiply both sides by that denominator, I get y minus y1 equals m times x minus x1. Let's do an example. Find the point-slope equations for the two lines that are shown. So how about number 1? So the name point-slope tells me that I need two pieces of information. I need a point and I need a slope. So in line 1, there are several choices. Let's just pick a point that's easily recognizable. There we go. So we have a point, 1, 2, and I need a slope. What is the slope of that first line? Looks like the x goes over 2 and the y increases by 1. So change in y over change in x, 1 over 2. So the slope is 1/2. Now let's make the point-slope formula. So y minus y1 equals m times x minus x1. So y minus, let's see, y1. y1 is the actual y value. That's the 2 there. 2 equals m is the slope, 1/2, times x minus, and now x1 is the actual x-coordinate, 1. And that's it. So in this formula, remember the y and the x that are just the unadorned y and x, those stay y and x. But the y1 is the actual number I'm going to plug in. And the x1 is the actual number, the x-coordinate I'll plug in. And the m is the actual slope that I will plug in. How about line 2? Pause the video, give it a try, and see if you can come up with the point-slope equation for line 2. Start up again when you're ready to see the answer. Alright, let's check it out. There are several different points you could have chosen, and it really doesn't matter. Let's just say I pick the point -4, 2. So I'll pick the point -4, 2, and I'll pick slope. Well, I can't pick the slope, there's only one slope here, and the slope looks like it is -3. So y minus y1 equals m times x minus x1. Let's plug in where I can. So y minus, what is y1? That's 2, equals -3, there's my slope, times x minus, now x1 is the actual x, so that's -4. And maybe I can just dress this up a little bit more nicely. So -3 times x plus 4. And there it is. Let's take a look at a different form, the SlopeIntercept form for the equation of a line. And this happens when the line crosses the y-axis at a nice point, like 2, 3, or -5, a nice integer. This is often a simple form to use. It goes like this. This line that you see here, it goes through the point 0, 2, and the slope of the line is 1/3. So by using the previous version, by using the point-slope form, I can see that the equation for the line is y minus 2 equals 1/3 times x minus 0. And here's the simplifying part. That 0, well, the 0 goes away, and so I could just write y minus 2 equals 1/3 x. And then let's go ahead and add 2 to both sides, and I get y equals 1/3 x plus 2. That is the slope-intercept form of the line. I can see the slope right there, there's my 1/3, and I can see the intercept right there. The intercept of that line is 2. Here's the process in general. In general, if a line with slope m has y-intercept b, now the intercept is just a number b, but that also means that it passes through the actual point 0, b. So if a line with slope m has y-intercept b, then it has equation y equals mx plus b. So m represents the slope of that line, and b represents the y-intercept. Alright, so how about, once again, we have two lines. Let's find the slope-intercept form for their equation. Again, two pieces of information. I need the slope and I need the intercept. So for line 1, let's see here, the slope, or I guess I could just call this m. What is it? This one's a little more challenging. Let me pick two lattice points. What is the slope of that line? Looks like I go over 3 and up 2. So my delta x equals 3, delta y equals 2. So delta y over delta x, 2/3. And what is the y-intercept? Oh, it looks like 2. So y equals mx plus b, 2/3 x plus 2. And there is the slope-intercept form of the equation for that line. Once again, pause the video, give line number 2 a try, and unpause it when you are ready to check your work. Here we go. Line number 2. I need a slope, m. The slope of that line looks like it's -2, right? My delta x is 1, but the delta y equals -2. So delta y over delta x, change in y over change in x, -2 divided by 1, that slope is -2. And the y-intercept for line 2 is, looks like -3. So y equals mx plus b, so -2x plus a -3, or I might as well just say y equals -2x minus 3. There we go. One last way that we can find the equation of a line is if we are given 2 points. Notice that in all of these equations, we start off with 2 pieces of information. In the first case, we had a point and we had a slope. In the second case, we had a slope and the y-intercept. And in this third case, we know 2 points. So there's a variety of situations in which you can take given information and figure out the equation of the line, either a point and a slope, or a slope and an intercept, or 2 points. All right, let's see what we do here. What is the equation of a line going through the points 2, 1, draw 2, 1, and 5, 2? There's 5, 2. So I need to figure out a slope. Given these 2 points, I can figure out a slope. So I'll do my change in y, so 2 minus 1 over change in x. That's 5 minus 2. So I get 1 over 3. So the slope of this line is 1/3. And I know a point. So in fact, I could take either of these 2 points. Which one looks simpler? Maybe 2, 1. And now, you know what? I have enough information that I could take a look at this first form, the point-slope form. I have a slope, I have a point. Let's use the point-slope form. So y minus y1 equals m times x minus x1. Y minus, what is my y1? Oh, just 1 equals the slope times x minus, and what is the x1? That's 2. There it is. And I can stop right there. I have created an equation involving x and y, and that equation describes all the points on that line. One more example, and again, this is an example where you should pause the video and give this a try, and then unpause when you're ready to check your work. All right. To calculate the slope, I take change in y over change in x. So that is -8 minus 1 divided by -4 minus -3. So -8 minus 1 is -9. -4 plus 3 is a -1. And so it looks like the slope is 9. For a point, I can pick either of those 2 that I was given. So how about -3, 1? And so the equation y minus y1 equals m times x minus x1. How about y minus, let's see, y1 is 1 equals 9 times x. And so I'm going to subtract a -3. And so instead of subtracting a -3, how about I'll just call that +3, and we are done. And so that's it for today, what I want to talk about in 2.3. There will be one more lesson in the future on 2.3, but this was a nice little section where we talk about the connection between equations and lines. That's it.